Welcome to Let's Code. I'm here with Jakub. Hello, Jakub.
Hello.
Thanks for joining. Now, as you know, this is a long-running, never popular series where we are working on a space game in Go. It doesn't really matter what the project is. The point is just to sort of film the development process and for people to have some fun watching us make mistakes and screw up. That's always fun, isn't it?
Yeah.
So that's what we're going to do. So it's been a while since I last looked at this project, and you haven't seen it before at all. So that's kind of okay, because it's sort of that's the kind of situation that we often face as developers in real life, as it were, isn't it?
Yeah, we are landing on brand new project and it's like a blank card.
Yeah, exactly. Or, sometimes like as a consultant, I'm sort of parachuted in, and they say everything's terrible. All of our code is on fire. Please deal with it. So I have to try and figure out what's going on, find my way around, see what I can refactor. And often my way in is by baby steps. I sort of what I feel I should do is read the entire code base, try to understand the architecture, work out what all the different bits are and how they connect to each other and so forth. I can't do that because I'm not smart enough. So what I tend to do is just find something, start anywhere, find something that looks interesting. Maybe I find a couple of lines where I'm like, I think I know what's going on here. That's helpful, gives me a foothold, right?
Yeah, that's always good starting point. Myself, I always, when I see the make file, it's my first actually, step to have a look what is in make file and run the make tests.
Right.
Or
Yeah.
run directly tests, for example, in Go code.
Yeah. Exactly. That's a great point, because the tests themselves, apart from being tests, which is very useful to have, they're also sort of a way of explaining what the behavior of the program's supposed to be, isn't it? Or at least that's how I think about it. When I'm writing tests, I'm interested in testing some behavior that it's supposed to do. And this is a little different to the kind of thing we normally work on because it's a game. I've never written a game before, or not in Go anyway. So it's quite interesting for me, and I'm sure people who do develop games professionally in Go will be screaming at the screen and saying, "What are you doing? That's all completely wrong."
The same for me. I never developed a game.
Yeah, exactly. But I figure it's just a program, right? We can do
Yeah.
this. Or if not, we might learn some interesting things along the way. So the origin of this game is called Lunar Lander, which was sort of, I think the first iteration of this was on a mainframe machine in the 60s, where, they actually were using mainframes to sort of compute real lunar landings, weren't they?
Yeah.
And I guess somebody said, as long as we're writing the simulation, we could play it like a game. You could actually you could model the lander descending to the moon, let's say. We know it has a rocket engine on board. We can model how much thrust you would get from it. You can throttle it up and down. We know how gravity works. We can simulate that. So, in theory, it's sort of like a flight simulation with just the landing part and without any aerodynamics. You're just descending under gravity, and the only control you have is basically more or less rocket thrust. And what you'd like to do is balance that so that you descend gently and settle to the ground in a soft way, such that you'd be able to walk away from it. Ploughing into the lunar regolith at 100 meters a second, would probably be bad. So this is quite nice for a game because it's entirely text based. That's all they had then. And we can do graphics, but we're not there yet. It's on our features list. So actually, if you have a look at the README, I've scribbled down a few ideas. Every time we thought of something and we said, yeah, that's a
Let me
feature,
open. Yeah. Okay.
we put it in the README sort of to do. Fuel, There's no concept of fuel at the moment. You basically have infinite fuel. Whereas that's not the case for the real landers, as you know. On Armstrong and Aldrin's landing, there was actually a serious danger of running out of fuel. So we would like to model that. And a few other things which we'll maybe get to. But perhaps, perhaps we should start by looking at the tests, and we can kind of use this as a way of saying, how explanatory are these tests? Do they actually tell us what's really
so
going on?
let me open the lander tests. So let's have a look at the very beginning, line 11.
Yeah, see what you can deduce from this.
Yeah, so we have a basic test. Actually, we are checking if it's possible to create the game object itself, right? We've given parameters.
Yeah, and we already learned something from that, didn't we? In the sense that you could imagine the state of the game is sort of global. The lander is at altitude X, the rocket thrust is Y, and so forth. But that's not what we've done, because you could actually imagine more than one game being played at once, couldn't you? Like, if this was an internet Lunar Lander server, you might have several people each playing their own game. So we actually need to keep that state in something, don't we?
Yeah, so we are keeping this state in a struct lander state. So this is state per lander, yeah.
This is a completely familiar situation to us, isn't it? Because they're all Go programs. You probably have some state of some kind, and the only question is, well, where does it go? Should it be global, or should we put it in something? Nearly always the second one, isn't it?
Yes.
So what we put it in is actually there's a lander.game object, and it has a state object inside it. Not totally sure if that makes sense. It's just that's as far as we've got.
Okay, so we have the lander new game, so we see that it returns the game object, and just in case something goes wrong, we have the return error. So before even diving into the code itself, let's have a look on the rest of the test. So if we are not able to create the lander, we are immediately bailing here, returning the fatal, because there is no point to continue with tests. Right. If we are not able to create this object, new game, and the test basically finished at this point.
Right, so you might say, what error could new game return? Because it doesn't take anything, so there's no input to be wrong. The answer is basically nothing at the moment. But when we were working on this, we said, you know what, there will be a point where it can error. So we may as well put that in now, because we're bound to need it later.
Okay, so for me it's like now black box, because I don't know what is inside the game. We're just going through the test code and analyzing. Yeah.
Exactly, but since we can see what the game object looks like, we have an example of it in want. It's just a struct value, isn't it?
Yes.
So new game probably just returns that literal struct. I wouldn't be surprised. We'll find out. I can't remember.
Okay, so we have now next step in the test, comparing if the lander new game works correctly and returns the game object as described if the want variable.
Yeah, every game starts the same way, and we know exactly what the parameters will be, so we can compare it. And it kind of seems from this like there are basically 4 numbers that express the entire state of the simulation, isn't it? You've got the altitude of the lander above the moon, or other planetary body. Other planets, I think, was another feature we were going to add. That's
a good idea.
Yeah, let's rein our ambition in for a moment and just see what else there is. So velocity, essentially, we've ignored any components of the velocity which are not straight down, or straight up, actually, in this case, because we start at -100. The we don't express units here, but a sensible choice would be meters per second, wouldn't it?
Yeah.
So I think that's what it is. And also gravity is, again, units not expressed, but meters per second would make sense, wouldn't it?
Yeah.
And thrust, which starts at 0 and will probably change. Now the gravity probably won't change throughout the game unless there's a major gravitational wave event nearby, like two merging black holes. That would be a nice feature. But we don't have it now, so maybe actually gravity should just be a constant. I don't know. That's a possible.
Could be at least where as long as we are dealing with only with one planet, right? We can assume that we can have the same gravity.
Yeah, exactly, and maybe that's just a factor of the selected planet. Or do you remember there used to be a game called Thrust back in the 80s, which I remember playing, where it was a graphical game, 2D. Where you control a rocket, and you're sort of descending under gravity, but you can point and thrust the rocket to stay airborne, and you sort of navigate your way through systems of caverns and pick up objects and tow them back to orbit and so forth. And one feature of this was, actually the gravity got more as the difficulty level went up, so it became more and more difficult to actually keep your ship from crashing. So that's something we could do. Is it increase the difficulty level, by having more gravity. We don't have that yet, though. So it's just the basics, and that's absolutely right, isn't it? We should try and get something really simple working rather than something really complex that doesn't work.
Definitely, yeah.
It's certainly a much nicer place to be in as a programmer, isn't it? It's like I have something that works, now I can maybe add a feature to it rather than I have 100 features but none of them actually do anything yet.
And this is very, very much very important in engineering. Make it work, then make it better.
Yeah, absolutely right. Okay, so that's the first test, and then clearly.
So let's have a look in the second test. Already, yeah. Okay, so we have the tests of the function display state. So we are creating the new game here in the same way like in the first test. So this is our first step.
Yeah, but this time we're not testing anything about it. We just assume that works.
Yeah, just in case we are in the same way like in first test, we are checking if we got an error just in case to stop the test, because it's no point to continue if we can't actually create the main object.
Yeah, exactly. Now, I'd be interested in your opinion about this, because what I used to do was I used to have some test that it's like call new game and check that you don't get an error. That's part of the behavior I'm testing, is that you don't get an error, or that you do for invalid inputs. But then for other tests, you obviously need a game, of course, to test against. So I would call new game, but I would ignore the error, because I'm thinking to myself, I already know there won't be one because the other test verifies that, right?
Mm-hmm. No, I definitely like this approach because, first of all, we have parallel tests. Maybe, for example, maybe we would have the new game function that returns the new object, do some computation.
Yeah.
Does some computation. And then, for example, in certain tests, we have the situation that the game object can be instantiated, but unfortunately, at some point, we could have some parameters that make the crash.
Yeah.
And then we wouldn't be able to catch this situation.
Yeah, that's a great point, actually. I hadn't thought of that. But what I did start to think was, if new game really doesn't work for some reason, then sure, test new game will fail. That's expected. But test display state will also fail, and I won't understand why.
Mm-hmm.
Because, I'll call g.displaystate, and I'll probably just get some meaningless error. And I'll be like, why is that test failing? And what I really want to know is it's because new game didn't work. But I won't see that if I don't check the error.
Yeah, that's a valid point.
So this is what I've started doing, is I've started saying, you know what, just always check errors. Nice and easy to remember, isn't it? So I was thinking to myself, there's a case where it is okay to ignore errors, because you already proved that there can't be one from another test. But now I just think, Yeah, there's no point in doing that. I expect that my tests will fail at some point. And when they do, I want the failure message to be meaningful, not, some panic or something.
Yeah, yeah, exactly.
Because it's easy to get into that way of thinking, isn't it? When you're working actively on the program, you are keeping some of it in your head, So when things like that happen, you go, of course, it's new game that's broken. I just touched it. That's what it must be. But if you come to this after, what is it now, 5 months,
Yeah.
you'd have no chance at all, would you? You'd just be completely mystified. So I do this as a gift to my future self, let's say. We should be
Yeah,
nice to our future selves,
exactly,
shouldn't we?
exactly.
They're older, you know.
Uh, and especially the situation right now that you are coming back after 5 months to,
Yeah,
to the code that you were developing. And for example, I see this for the first time. So it's similar situation that, for example, you are back to the code that you wrote. Maybe you forgot a lot of this kind of stuff. So it's easier to actually have a look into the tests and figure out quickly, okay, what I was doing 5 months ago.
yeah, exactly. I think we should always err on the side of being a little bit more informative than we think is necessary, shouldn't it? Or if you're ever asking yourself, should I be more or less explicit here? Just go for more.
Yeah,
You'll
yeah.
thank yourself.
And
Yeah.
especially if you are involved, let's say, in multiple projects,
Oh yeah.
then it will end up 1 or 2 weeks, and you will really thank yourself that you actually were more expressed.
Yeah, and or if there are multiple people working on it, because then, a ton of people. I mean, maybe it's only a week since you looked at it, but there have been 100 commits by other people since that time,
Yeah,
and now you have no idea
exactly.
what's going on. They've added hyperspace or something. So also, I think this is kind of nice because for anybody watching at home who has, set out on some programming project with great intentions and high ambitions, and then sort of it just got parked for some reason. Life supervened as a way of doing that, doesn't it? You unexpectedly had kids or something, and then you weren't able to work on it for a while.
Yeah,
But that's okay because you can come back to projects and you can pick them up and carry on with them if you want to. No shame in just abandoning them if that's really what you want to do. But if you sit in there every day thinking, I wish I hadn't abandoned that Go project, I'd love to get back to it, but I'm sure it'll be too hard. Take courage because I think you can, especially if you leave yourself plenty of tests and explicit test failures and things. You will be able to, or we'll see if we can. And
yeah,
if so,
exactly. Yeah.
that'll inspire others, won't it? Hopefully. So yeah, let's carry on.
Yeah, so we already see here that we have some expected string. So basically the want. So we see that we need these parameters from the new game object printed out. Just a quick note that we don't expect to see gravity.
Right.
Comparing, yeah.
So essentially, like all simulations, there is some concept of a time step. A game tick, if you like. The numbers are what they are at a certain moment, and then we move forward one game tick. We apply physics to calculate what the new numbers should be,
Yeah.
and just repeat. And that's it, isn't it? And all games are conceptually just this loop, aren't they? For while running, compute next tick. And in this case, display it. So we want to tell the player at each point what the numbers are. This is their head-up display, if you like, or it makes up for a lack of graphics. We don't need to tell them gravity because that's constant, and because we don't have graphics, we're just going to print this out as a string, and of course that'll really be on the terminal when they're really playing, but that's no good in a test.
Yes, so on the line 37, we created a new buffer, but I would say the interesting is line 38 because it gives us the first clue what kind of method we have on the new game object.
Right.
So we are calling display state. And then we have the got variable. So we are getting basically in form of the string representation of this buffer.
Yeah.
And our first assertions in this test, and only one actually, and we are testing if basically wanted is the same as we got, passing this want and got variables to our string.
Yeah, exactly. So, you know, this is a problem that faces everybody who wants to write programs that produce output, isn't it? Like, how do you test that? You know, and it's very common for somebody to come along and sort of think, right, I need to write a display state method. Okay, I'll just print what I want to print. Okay, now I'll write the test for that. Well, actually, now I have a bit of a problem because I can't look at the terminal. I don't have access to that.
Yeah.
And also, I don't want anything appearing on the terminal while I'm running tests. All I want to see when running tests is just test failures. You know, if you see 100 different printouts from different tests doing things, then it's just impossible to read the output. So maybe we can use one problem to solve the other. You know, if instead of just printing to the terminal, I just give you some IO writer to write to, then that stops you writing to the terminal because you're writing to my writer. And if it's a bytes buffer, I can also look at it and say, hey, what got written?
Yeah, so this is exactly line 39 that we are getting string, and then we can actually figure out what was this message.
Yeah, we know exactly what it will be.
Yeah. Okay, so shall we go to line 45 that we have next test?
Yep. There's actually not a ton of tests here because the game really doesn't do a lot yet, although it is playable and we can play it.
Okay, so we have the tests that tells us that we are testing the method read trust. And again, the same approach that we are testing if the new game object is created correctly. Otherwise, we are basically stopping the entire test, running the test suite.
Yep.
We create the input, then creating the output as well using the buffer, bytes buffer. And then we are calling the read trust, the method on the game object. And is similar, the logic like in the previous test, we are creating the got variable, assigning the trust to this variable, and then in the go way we are comparing if what we want is what we got. If it's different, then we are basically debating tests of getting error.
Right. So what can you deduce, if anything, from this? Any failure of deduction on your part would not be your problem. It would be due to the person that wrote the test. Because that's part of its job, isn't it? To sort of make it explicit what's happening. We know about the new game bit. We must have a valid game in order to do anything. And we're saying if you construct some bytes buffer that has in it the string 10 followed by new line, and then you pass this to read thrust and give it some throwaway output to write to, and then what do? It doesn't, read thrust doesn't return anything. You could imagine that it would, couldn't you?
Yeah.
It might return the thrust setting, for example. So this is basically, this is the player's control, if you like. Is the control they have is they can type in the rocket thrust they want, and we need to correctly read that. But it doesn't return anything, so we don't look at that. What we do is we look at the G again, the game object, and we say, well, what's the thrust number on the current game state?
Yeah, so it looks like we are dealing with the pointer semantic, that we are basically assigning inside the read thrust values from our output.
Yeah, it should maybe be called something like set thrust, based on user input. Or we can bike shed the name later, but yeah, as you say, it effectively it asks. I know why it takes output, because it prompts the user to say, hey, type in your thrust now. And then it reads it, parses that into a number, and then it sets it on the game. It says the thrust is now 10, or whatever it was, but we're using 10. So this test is checking that whole behavior.
Yeah.
Which is kind of nice.
Our last test, we have update world. That's interesting, the name. Okay, so the same behavior. We are running this test in parallel. So I don't know if we mentioned about this yet.
Yeah.
But as well, we are making sure that our new game object is created successfully by checking the error.
Yeah, that's right. And yeah, we generally want to run our tests in parallel, don't we? Unless there's some reason why not. Partly because, I have 8 CPUs, I've paid for them, so might as well use them. I can run 8 tests at once. And the other thing is, because the tests are all concurrent, then if I do have any concurrency problems, any data races or anything, it's likely to blow up some of my tests at some point. So, I should never be in that situation, but if I accidentally goofed somehow, then hopefully I might be the first person to notice it, rather than, I launch it to 10 million players on Xbox, and then the bug reports start to come in.
Yeah.
That would be a bad situation, wouldn't it? So I always want to suffer my own bugs first before anybody else.
I see this as a reminder that we should always write the test as a self-contained units, because I saw a few times actually unit tests that they basically depend on the order of execution, which actually make the unit test completely not usable and very, very actually not reliable at all.
Yeah, you're right. I think I remember reading something about how the test order is going to be randomized. Did you see this?
No, not yet. But...
Maybe I just dreamed it. That does sometimes happen. But I think it was, so basically I don't know what order tests run in at the moment, but it's probably just, whatever. Whereas what they're going to do is, because as you said, if the tests depended on ordering, then they might accidentally just always run in the right order and you'd never notice. So to flush out those bugs, they're going to randomize them every time you run, so that they'll run in a different order. And that should hopefully catch any dependencies like that.
Yeah.
If not, it's a good idea though, isn't it?
Yes.
I think we should definitely do that. Maybe we can simulate that by just, shuffling our tests around in the file every so often.